Hello, class. I'm going to give a somewhat brief lecture on erythroblastosis fetalis, also known as hemolytic disease of the newborn. Erythroblastosis fetalis is actually an immune response that the mother's immune system engages in and crosses the placenta and starts to attack fetal antigens on the fetus's red blood cells. When this happens, even after the baby is born and the hemolysis continues, we call it hemolytic disease of the newborn. So they both are addressing the same thing, the mother's immune system going on the attack. Erythroblastosis fetalis occurs while the fetus is in mom, and the attack can continue once the baby is born, and then we call it HDN. It's important for us to review some basic terms. One, an antigen is something on the surface of a cell membrane that can provoke your immune system into action. This substance can be a protein, it can be a sugar, it can be a combination of a lipid and a sugar. So it's anything that can provoke your immune system. There can be viral antigens, bacterial antigens, and your body has to have a way to identify self-antigens versus non-self antigens. Non-self antigens, your body should have an immune response to, but having an immune response to self-antigens would be inappropriate, and that would be an autoimmune disorder, and that's a different lecture. Our B lymphocytes, when they mature into plasma cells, they produce antibodies. And antibodies are very specific to a particular antigen, meaning we make one antibody that can recognize an antigen. If you come across another antigen, you would need a different B lymphocyte to make that antibody. So B lymphocytes make only one antibody type when they are mature into plasma cells, and this would recognize only one antigen. So here's a picture showing a bacterial cell, and all the different colors and shapes represent different antigens that that bacterial cell has. And you can see that antibody A recognizes the red triangle antigen, and antibody B recognizes the half circle peach antigen. Clearly, antibody A would not be able to recognize the half circle peach antigen. That's what I meant by your B cells make one antibody specific toward one antigen. And I also talked about on the previous slide self-antigens. Because we're talking about hemolytic disease of the newborn, it also does go along with blood types. And I'm not going to lecture on the different kinds of blood types. You should have learned that in physiology. My pictures down at the bottom show you 4 different types of red blood cells, and I used shapes to illustrate the different antigens they would have. If you are blood type A, you would have the A antigen, and I showed that here with a triangle-shaped antigen on the red blood cell. If you're blood type B, you would have the B antigen, and I show that here with the yellow circles as antigens. If you're blood type AB, you would have both those types of antigens, A and B. And if you're blood type O, you would not have those specific antigens expressed in your red blood cell membrane. Specifically, just to remind you from physiology, the ABO blood type antigens are actually a chain of sugars, and it's the last sugar of the chain that determines your blood type. So if you are blood type A, specifically your antigen is a sugar called N-acetylgalactosamine. If you're blood type B, you have galactose as your terminal sugar. If you're blood type AB, you would have both of those sugars expressed in your red blood cell membrane. And if you are blood type O, you would lack that last sugar in that chain of sugars. Now, our focus today will be on blood incompatibility between mother and her fetus. There can be incompatibility between the ABO blood groups, and I will address that. But another antigen is expressed on the red blood cell membrane. This antigen is a protein, not a sugar. And this protein basically threads itself through the red blood cell membrane many times. We say it's serpentine, like a snake. And this protein is called Rh factor because it was first discovered in rhesus monkeys, spelled R-H-E-S-U-S. Some textbooks and papers, instead of saying Rh factor, they will say the D as in dog antigen. So be ready to see or read both of these types of terms. Now, these antigens that are in your red blood cell membrane, we can give a more specific term. They are called agglutinogens. So if you are blood type A positive, you have the N-acetylgalactosamine as your sugar, and you have the Rh factor threaded through your red blood cell membrane. Both would be your agglutinogens. Agglutinins is a term to refer to the antibodies that would be produced by B cells that you have against blood antigens or agglutinogens you don't have. For example, in the top left box, we see a person with blood type A. Their A antigen is shown here in green. Of course, we know now that means they have the sugar N-acetylgalactosamine. Now, their B cells would produce anti-B antibody. Their B cells would produce an antibody against a blood type that they don't have. It would be inappropriate to make an antibody against a blood type you do have. That would not be compatible with life. If you're blood type B, then you would make anti-A antibodies from your B cells. If you're blood type AB, you would not make antibodies against either the A antigen nor the B antigen. And if you're blood type O, you would make antibodies against both the A antigen and the B antigen. We can add to this story if we add to the conversation the idea of having an Rh factor in your red blood cell membrane. If you do have the Rh factor, we say you are positive. If you don't have it, we say you are negative. So if you are A positive, you would have the N-acetylgalactosamine and you would have the Rh factor. You would make anti-B antibodies. If you are A negative, you would make anti-B antibodies and anti-Rh antibodies, or anti-D, or anti-Rho is another term for the Rh factor, or the antibody in this case that I'm talking about. It's important, and I'm sure you learned this in physiology, not to give someone a blood transfusion with blood that is incompatible. And the reason is if you give them red blood cells that their antibodies would recognize, then you're going to have agglutination. This is not a clot. Clotting is a completely different process. Agglutination is shown down here in the bottom left picture. It's showing antibodies reacting with cell antigens, in this case agglutinogens, and creating a complex. These complexes can become so dense that they precipitate out of solution. When we are blood typing someone, we use that phenomenon to our advantage, and it's shown here on the right side of the slide, and it's the picture that says anti-A and anti-B. In the anti-A picture, you can see the agglutination process. Obviously, giving someone incompatible blood and having this process occur within them would lead to a lot of these complexes obstructing blood flow. Students sometimes ask, how soon do we start to see antibodies in blood against other blood types? And the answer is, you can see here, it starts either very shortly before birth or very soon after birth. You definitely are exposed to other agglutinogens, either through food or viruses or microorganisms delivering these agglutinogens to you in a variety of ways. The answer is you start to make these antibodies at a very young age. And a lot of times students think, oh, well, it won't matter what kind of blood type we give to a newborn. Yes, it does. Yes, it does. And that's something we're going to talk about more today. In this picture, I am doing my best using PowerPoint shapes to show you a red blood cell. And this red blood cell with the yellow triangles, I'm trying to represent that would be N-acetylgalactosamine. And with the green rhomboid shape, I'm trying to represent the Rh factor. So this red blood cell, if we had to give it a blood type, would be A positive. Now, you should know from physiology by now how to identify someone's blood type, how to identify what antibodies they would make against foreign blood types, meaning blood types they aren't. And you should also be able to recognize which blood types you could safely give to someone. Most of you want to be nurses or future physician assistants, and this is going to be a very important skill. You don't want to kill someone, after all, over something so silly. You need to know that these red blood cell antigens, the sugar groups or the Rh factor, they have different antigenicity. They have different severity. If you give someone who has blood type O a blood type A transfusion, I assure you those sugar groups are very antigenic. You will see agglutination in your patient very rapidly. Their life will be compromised very quickly. We say it's very antigenic, meaning it will provoke the immune response in that recipient very quickly. However, there are some red blood cell antigens that are not as antigenic. They can, like Rh factor, it can be mildly annoying, if you will, to the recipient's immune system. Usually when I'm teaching this face-to-face, I oftentimes joke with a fellow student in the classroom. I might find a student that's wearing a particular color of eyeglasses, let's say green. And I'll come up to that person and I'll say, these green eyeglasses you have, you know, it's just not, I find it a little annoying. I don't like green. And I'm not going to kick you out of the room right now, but next time I see you, could you please wear different color eyeglasses? Wear your second pair. Or I'm going to get a little intense with you the next time I see you with those green glasses on. And that seems a little silly, but that's how some antigens can be. They can be mildly annoying to your immune system, and if your immune system could talk to you, it would say, nah, I'm not going to go after you right now. I'm not going to kill you right now. But if you keep bringing this antigen around to me, I am going to get more and more angry at it. I'm going to have a stronger response to it. This kind of response that our immune system has to those antigens is very similar to why some immunizations you need multiple exposures to them, multiple rounds of it. For example, hepatitis immunizations. For hepatitis B, you need more than one immunization. Again, it's to increase the immune response to that antigen. So it turns out Rh factor is a lot like this. It is not as antigenic as the AB sugar groups. However, clinically, it is very important. And even though it's not very antigenic, it actually comes to the top of our thinking when we're worried about a mother carrying a fetus, and the fetus has a different blood type than the mother, because the mother's immune system can go on the attack. That fetus is going to be in that mother for about 40 weeks after all. And that invites plenty of opportunity for the mother's immune system to become more and more alarmed, more and more intense. So I'm going to explain this in more detail over the next few slides. So where can we have, how can we have blood incompatibility between mother and baby? Most of you are not going to pre-select a mate based on their blood type. Most of you won't. And if you're female out there and you want to get pregnant, I assure you, you're not going to pre-select for a sperm donor from a person that has the same blood type as you. You're probably going to be interested in other things, like the overall appearance of that person and those types of genetics and how compatible are you, etc. Most of us don't go out and meet someone and say, hey, before we get too serious, what's your blood type? Well, nope, that's not the same as mine. Bye. So we can have blood type incompatibility between the mother and fetus over the ABO blood groups. It is very likely that the mother will become pregnant with a child, a fetus, I should say, from a sperm donor that likely had a different blood type than she did. That is very likely. We also can have incompatibility between the Rh system. Maybe the mother is Rh negative and the fetus is Rh positive. Now, it turns out the great majority of the people that live in the United States are Rh positive. It is more rare to be Rh negative. So if we ever have a woman who is Rh negative and is pregnant with a fetus, we immediately assume the worst. And that means we assume that she is pregnant, that her fetus is going to be Rh positive. And we start to address that Rh incompatibility right away. We're really not so concerned about the ABO incompatibility. That is also extremely common. So why would we clinically be more focused on the Rh incompatibility instead of the ABO incompatibility? It all comes down to time being on our side in one of these cases, but not the other. So again, how can we have HDN, hemolytic disease of the newborn, or if it occurs in utero, erythroblastosis fetalis? Fundamentally, the mother lacks a trait that the fetus has. For example, The mother might be blood type O, but her fetus is blood type A. The mother does not have the A antigen, but the fetus does. Of course, that antigen is the sugar N-acetylgalactosamine. Or in the case of Rh incompatibility, the mother lacks the Rh factor, but the fetus has it. The mother then, her immune system must be provoked, must be exposed to that fetal antigen. So that is the only way her B cells are provoked into action. They must bind to the antigen and mature into plasma cells and start making the antibodies. Now, in ideal situations, the baby's blood and the mother's blood should not mix while the fetus is in utero. They have totally different, separate blood circuitry. But can blood mixing occur? Can the mother's body have some fetal red blood cells get into her bloodstream and provoke her B lymphocytes into action? Absolutely. When can this happen? At any stage of the pregnancy. There can be transplacental tears at any time. We might actually have a woman do an amniocentesis where a large needle the size of Excalibur is pierced through her abdomen into the amniotic sac. That is an invasive procedure. It's going to invite bleeding. It is very likely that fetal blood cells will get into the mother's circulatory system. Any time there is fetal and maternal blood mixing, this can provoke the mother's immune system. It can happen during birth itself, whether it be a vaginal birth or a C-section or a termination of the pregnancy. The take-home message is many times there can be mixing of the fetus's blood with the mother's blood. And that's all it takes for her immune system to become provoked. And once that happens, we can't really shut that down quickly. So let me go through the kinds of incompatibility again. Can there be incompatibility due to mom having a different blood type, ABO blood type, than the fetus? Absolutely. Extremely common. Probably going to happen. Again, most of my female students do not select a mate based on the mate's blood type. So this is very likely going to happen. This is the most common opportunity for hemolytic disease in the newborn. However, clinically, we're usually not that worried about it. And here's why. Time is on our side. The fetus does not express the A antigen or B antigen or A and B until almost around birth or shortly after birth. That is the reason why blood typing a newborn child is extremely difficult. They don't express the antigens. They don't express the enzymes that place that last sugar on the end of the chain. So time is on our side. The gene expression just isn't there yet. If ABO incompatibility does occur, it's usually significantly less severe than the Rh incompatibility I'm about to tell you about. So very mild. And I will tell you about some of the complications of HDN. And the complications for these babies when they're born with ABO incompatibility with their mother, very mild, very easily addressed. So extremely common, but clinically, I'm not saying we don't care. I'm just saying usually we don't have to worry about it. But HDN due to Rh incompatibility, less likely to happen because you just heard me say most of us living in the United States were Rh positive. But anytime we see a mother that is Rh negative, shown here in picture number 2, if she is pregnant with a fetus that is Rh positive, And if some of those fetal red blood cells with the fetal Rh antigen on them gets into the mother's bloodstream, it will provoke her immune system into action. Most textbooks say to you that the mother carrying the firstborn child, in this case with the Rh incompatibility, we don't really need to worry about it because it's not until she gives birth that her immune system will now become provoked because of the mixing of the blood during the birthing process. And it's the next pregnancy that we have to worry about. Really? I beg to differ. I just explained to you that maternal and fetal blood mixing can happen at any stage of the pregnancy. What if this woman is pregnant with an Rh positive fetus and she has a transplacental tear in the early stages of her pregnancy but doesn't lose the fetus? Her B cells will definitely be heightened into awareness, provoked into action, mature into plasma cells, and make antibodies. How dare textbooks say to you, oh, she's fine with the first pregnancy, it's the subsequent pregnancy. All right, what about another example? Do you know that some women lie about having been pregnant previously? Some women, if they have had a miscarriage or aborted a pregnancy, don't like to admit to those things. They are painful memories. Many do not disclose this to their physician. So how would you know? Do not assume. I tell you, anytime you have an Rh negative mother pregnant with a fetus, you assume and plan for the worst. You, one, assume the fetus is Rh positive. Yes, even if the mom says to you, no, my honey is Rh negative. We can blood type my honey and I'll prove. I don't care. That mom can tell me all she wants that her fetus's co-parent is Rh. I'm not going to buy it. I'm not going to buy it. Mostly because I have too many cousins that don't even know who the father is for their own children. I'm going to assume the worst. Number one, that the fetus is Rh positive. Number two, I am going to assume that the mother is already sensitized to that antigen, to the Rh factor, like shown here in picture 3. I am going to assume that that mother's immune system is already primed to go on the attack. And you need to know something. If those antibodies shown here as the green Y structures are made by the mother's B lymphocytes, they are IgGs and they are small enough to cross the placenta and they will get into the fetus's circulation. And those antibodies will start to attach to the red blood cells in the fetus, cause agglutination like I showed you in a previous picture. Now you've got inadequate blood flow to developing structures in that fetus, and you've got red blood cells that are lysing from that complement system. That's why we call it hemolysis, hemolytic disease of the newborn. Erythroblastosis, the red blood cells are being blasted apart. Fetalis, in the fetus. Now you have reduced oxygen carrying capacity in that fetus. Structures that are developing are not getting oxygen. How do they develop properly? So you see, you assume the worst. You assume if you have a mother that is Rh negative, you assume her fetus is Rh positive, and you assume her immune system is already primed for the attack. So now the question is, what do you do about it? Well, we can try and prevent the mother from going on the attack. We can try and prevent her antibodies from crossing the placenta. Well, how do we do that? We can give an immunization called Rhogam. Rhogam is anti-Rh antibody. Let me say this again. Rhogam is anti-Rh antibody, anti-D. It's the same thing the mother's immune system is making. The same thing that I just said to you. Assume she's already primed to go on the attack. Am I making sense to you right now? Because it should sound crazy. You're saying to me, Kara, we should inject the mother with more of the antibody that we're worried she's already making? Yeah. And here's why it's a genius idea. By injecting this Rhogam into the mother before her B cells are alerted to the fetus's antigens, we're doing a preemptive strike. Let me explain how. You see, the Rh factor is not expressed until after 28 weeks of gestation. That's where I meant we have time on our side. So even if mom is carrying an Rh positive baby, the Rh factor is not threaded in the fetus's red blood cells until after, a few weeks after 28 weeks of gestation. So if we give the mom the injection prior to the expression of the Rh factor, if any fetal red blood cells get into the mother's circulatory system, the Rhogam we injected will bind to those fetal antigens and neutralize them before the mother's B cells can get to them, react to them, and mature into plasma cells that are producing antibody against Rh. You see, the B lymphocytes, unless they can bind to the antigen, they can't become mature plasma cells. So if we pre-inject the mother, if and when she does get fetal red blood cells inside her circulatory system that have Rh factor, our immunization, our preemptive strike will get there first. This neutralizes fetal antigens. It's genius. We can give this Rhogam immunization at within 72 hours of delivery. We really need to. Anytime we suspect that there's been bleeding during the pregnancy, we can even give it if the mother is going to be having an amniocentesis. The idea is you can actually give a mother several doses of this immunization for a single pregnancy. Right about now, students say, well, Kara, Rhogam must not cross the placenta. It must be somehow different. No, it crosses the placenta. It's the same thing. It's the same antibody we don't want mama to start making. It's the same thing. Well, Kara, then clearly we can't give too many of these Rhogam shots to a mom in a single pregnancy. Well, you know, turns out we can. We have had enough documentation of this right now. Do you remember me saying Rh factor is not very antigenic? Let me explain things to you. Let's say we have 100 women that are Rh negative in a room in front of you. It's their first pregnancy. Honest to goodness first pregnancy. We assume they are pregnant with an Rh positive fetus. If we do nothing, no Rhogam, nothing, how many of them will have a child that has complications of blood incompatibility due to Rh factor? How many out of 100? If you're going back to that picture that shows, like I said, most textbooks assume that first pregnancy will be fine. Most students tell me, oh, 100 women, Rh negative with an Rh positive baby, first pregnancy, maybe 1 or 2. might have complications. I say that's a good guess. Okay, same women. Now it's pregnancy number 2. Second pregnancy, they have Rh positive baby. How many of them, if we do nothing, how many of them will have a child that will be born with complications with Rh incompatibility? And usually my face-to-face students will say, okay, now we're up to at least like 50, 75%. The majority of them will. And I say, well, turns out second pregnancy, about 5 out of 100, somewhere around there. And I do it again. What about the third pregnancy? What about the fourth? What about the fifth? What about the sixth? And they keep saying, well, it's got to be up. We got to get up into the 50% of them. There's got to be problems. And after the 5th, 6th, 7th, 8th child, it might jump up to 8 out of 100 of them. And then my students say, well, then why are you bothering us with this information? Why do we even care? 8 out of 100, even if it's the 10th pregnancy. I argue, if it's this easy to prevent HDN due to Rh incompatibility, if it's this easy by giving the mother this immunization and it helps prevent complications in 8 newborns out of 100, shouldn't we do it? Shouldn't we do it? I argue every mother should get to take home their take-home package as healthy as possible. It's their take-home prize. It's so easy to prevent. Dealing with the complications as an afterthought are much worse. It's so easy. Here are the complications if we don't prevent HDN, if we don't prevent it, and if the child, the newborn, has complications of this incompatibility, we got to treat the child. Now there's no damage control. The damage has happened. Now we got to try and put out those fires as quickly as possible. You see, mom's immunoglobulins, her IgGs, are still in the baby for about 6 more weeks. That's how long they can last in the baby, doing damage. So the first thing we can do is, if we know the fetus is in distress due to incompatibility happening while it's in utero, we can do an intrauterine blood transfusion. We can give the baby type O negative blood so that there is no antigen for the mother's antibodies to attack. There's nothing to bind to. We can do that. That has complications on its own. It can lead to a spontaneous abortion. Turns out a mother's uterus doesn't like to have needles going through it. After the baby is born, we can still give the baby blood transfusions. What do we give them? O negative blood. O negative blood. No Rh factor, no AB sugar groups for the mother's immune system to attack. And then after about 6 to 8 weeks or so, the antibodies from the mother that are still in the baby should be gone, degraded. We also can help, I'm just going to describe a picture. We can also help the baby with the complications after birth by putting them under the Billy lights. And that was like the sun tanning bed that you saw the baby lying in on the first slide of this lecture. You see, when there is severe hemolysis, part of the hemoglobin in the red blood cell cannot be recycled. And this is something called the porphyrin ring. And it must be removed from the body. It's a waste product. And when this happens, this waste product building up, it's called bilirubin. If the baby can't get rid of it. And well, why can't the baby get rid of this bilirubin? Well, the baby's organs that get rid of dying or damaged red blood cells, which is what we're talking about, hemolysis, is the liver and spleen. And they are immature. It's a newborn child, for crying out loud. And the liver is trying to do liver things without having a huge cleanup to deal with of dying red blood cells. So there's overload of this bilirubin that the liver and spleen cannot handle. And so the baby can end up having an enlarged liver and spleen, hepatomegaly, splenomegaly. Shown here in the bottom left picture is an enlarged spleen. Now that's not from a baby because that's the size of a baby, but this is not okay when the organs get enlarged like that from excessive workload. The child will be anemic, of course. This bilirubin that builds up because the liver and spleen are not able to clear it from the child quickly enough can lead to death of neurons. This is called kernicterus. So the bili lights, the sun tanning booth that I showed you in the pictures, they help convert the bilirubin from a form called unconjugated bilirubin to a form called conjugated bilirubin. And we'll be talking about this process in another lecture. The conjugated bilirubin is more water soluble, and that means the baby can urinate it out of the body much more readily. So the bili lights help with this chemical modification and reduces the workload of the liver. You see, it's the liver's job to do that chemical modification. It's the liver that is going to change the unconjugated to the conjugated bilirubin. So we can facilitate that reaction with the bili lights. We would prefer the children not to have neuronal death because this will lead to mental deficiency, severe retardation. So if we can alleviate that workload for the liver, we need to. I'm sure you can appreciate that all of these complications either happening before birth or after birth, honestly, if we can prevent them, we should. Now, I want to leave you with one more thought. The sugar antigens I just told you about, and the Rh antigen that I just told you about, and the maternal and fetal incompatibility that I just taught you. There are other antigens on red blood cells. They are more rare. There's the M, N, O, even S antigens. They are more rare. But in some populations, those antigens can be more predominant. And I have read papers of HDN issues, a child with HDN, because the mother did not have those red blood cell antigens, but became pregnant with a baby whose father had those more rare antigens, and severe complications occurred because the doctors weren't ready for it. They weren't familiar with it. And I oftentimes have on a lecture exam a question that addresses hemolytic disease in the newborn by using this example of these other more rare antigens. Again, it all comes down to the mother lacks a trait that the fetus has on its red blood cells. The mother's immune system becomes provoked into action. And once her B lymphocytes mature into plasma cells and make those antibodies, we can't stop her. The idea is to prevent her from doing that in the first place. That is why something like Rhogam is so brilliant. I hope you've enjoyed that lecture on hemolytic disease in the newborn.